Assalamualaikum. We are students from the College of Computing, Informatics and Media Studies, KPPIM, course Diploma in Statistics, CS111 from Class 1B, Group 5. Today, our group will present about related rates for group assignment MAT183, Calculus 1.
Bismillahirrahmanirrahim. Grateful to Allah SWT, we managed to finish this group project with His blessings and helps. Words cannot express how pleased we are of all of the support received from everyone. We would like to thank our MAT183's lecturer, Ms. Nur Fatihah binti Harun, who had been our biggest helper for teaching us this whole semester. She assisted us to plan and we were able to carry out our group project related rates. I am Nur Atika binti Muhammad Faisal 2022662938. On behalf of the group members, would like to extend my sincere thanks to my group members for contributing their time and energy to finish this assignment. Their cooperation created the greatest teamwork, and hopefully we will expand this energy into the next group assignment.
Hello and Assalamualaikum. My name is Nur Aina-Balkis binti Muhammad Zaidi. My matric number is 2022645526.
Assalamualaikum and hello, my name is Nur Atika binti Muhammad Faisal 2022662938.
My name is Karina Nafisa binti Zulkarnain. Matric is number 2022479712. So our group have chosen related rates, also known as rate of change, for this assignment topic, which is application of differentiation. For introduction, one of the application of differentiation in the fundamental theorem of calculus is related rates, which is rate of change. Related rates normally involving figure out the rate of changing of a quantity from another quantity that is given significant information. The related rates is known for its benefits in the application in life. An example of application in real life regarding related rates is we can figure out the speed of two vehicles that drive in different directions if each of the vehicle's speed and direction is known. What is actually related rates? In other words, related rates is one of the fundamental concepts of calculus. Is facts that the derivative is used to model the changes. The rate of change is usually expressed with respect to time. The objective of this topic is to find the rates at which one quantity is changing by relating it to other quantities with no rates of changes. Before we go far, we should ask what is actually dy over dx. Dy is actually the change of y and dx is actually the change of x. So when we write dy over dx, it should be the change of y with respect to the change of x. Next, we're gonna talk about the rate of change. If it is the rate, so we are going to talk about the time. Let's say we have dy over dt, so it should be the change of y respect to the change of t, which t is actually time. If you have dv over dt, so it should be the change of volume with respect to the change of time. Next, dA over dt, which is the rate of change of area with respect to the change of time. And the last one is dh over dt, which is the rate of change of height with respect to the change of time. Apart of that, we will have positive and negative rates. For example, we have dv over dt greater than 0. That means there is increase in volume with respect to the time. What if dv over dt which is less than 0? That means there is decrease in volume with respect to the time. Then we can make a relation, like for example, we want to have the dy over dt. Firstly, we can relate to dy over dx multiply together with the dy over dt. So then we can identify the answer.
Situation. A group consists of 3 students want to go to the library. Student 1 refill her water bottle at a water dispenser. On their way to the library, student 2 noticed that student 1's water bottle is leaking. The water inside the bottle has become lessened. Oh, there's water dispenser over there. Let's hurry up and go refill your water bottle. Hurry up, go refill your water bottle. Atika, why the water inside your water bottle is listening? Didn't you just refill your water bottle just now?
I just realized it has a hole under my water bottle. This is not enough for me to study while drinking.
Oh, I just remember we have learned about the rate of change last week ago in MAT183 class. Why don't we apply it on this situation?
Oh, that is a brilliant idea. So, shall we?
Yeah, shall we?
Let's go.
Problem statement. A cylindrical water bottle has leaking at a rate of change 15 cm³ per second, whose radius is always quarter of the height. Objective. Firstly, to show that the volume of cylindrical water bottle is V equal to 1/16 pi h³. Secondly, to determine how fast the height of the water is changing when the water bottle is leaking at h equal to 12 cm. Problem solution. First and foremost, we must identify the rate of change that are known and the rate of change that is to be found. Therefore, we have concluded that the rate of change of the volume is negative because it states that the water bottle is leaking. That means derivatives of V with respect to T is negative 15 cm³ per second, and the radius is equal to 1/4 of height. The objective of this case is to determine how fast the height of the water is changing when the water bottle is leaking at h equal to 12 cm. So, we need to find the rate of change of the height, which is derivatives of h with respect to t, and given that the height is 12 cm. Step number 2. We need to construct a formula or equation that relates to the variable in step 1. From this step, we can achieve objective of this case number 1, to show that the volume of cylindrical water bottle is V equal to 1/16 pi h³. From step 1, we have identified the rate of change of the volume, so we can construct a formula from formula of volume cylinder, which is V equal to pi r square h. Then, substitute the value of r equal to 1/4 h to the formula of volume cylinder and solve it, and we have got the value of V, which is V equal to 1/16 pi h³. Next, step number 3. We must differentiate both sides implicitly with respect to the time, and we can achieve objective of this case number 2. To determine how fast is the height of the water changing when the water bottle is leaking at h equal to 12 cm. From step 2, we have got V equal to 1/16 pi h³, and we need to differentiate V with respect to the time and get a derivative of V with respect to t. Then, multiply 3 with 1/16 and get a 3/16. Next, the power of 3 must minus with 1 and get a h squared. Since the h do not have t, we should differentiate with respect to the times and put derivative of v with respect to t. Last but not least, step number 4. We need to evaluate the equation using the known values from step 1. From the problem statement, we have done interpolates and got a derivative of v with respect to t equal to negative 15 cm³ per second, and the height is 12 cm. From the step 3, we have done differentiate both sides implicitly with respect to the time and got derivative of v with respect to t equal to 3/16 pi h square derivative of h with respect to t. Therefore, we must find the rate of change of the height. Then, we just need to substitute the values with derivative of v with respect to t is negative 50 and the height is 12 cm. Next, solve it by using calculator And the final answer is derivative of h with respect to t is negative 0.5556 centimeters cubed per second.
Aina, Balkis and Nafisa are able to complete this group assignment MAT183 before the due date. Despite the fact that we face numerous obstacles such as problem with time management and not understanding the topic, but after we apply this concept in our daily life, we managed to understand it better. Overall, we are very happy with our accomplishment. Based on this project, it can be concluded that the rate of change of the height of the water can be determined by manipulating and differentiating the function given. For this one, it's V to dV. The first step is to identify the question. What rate of change need to be found? For this one, it's dH over dt. Next, create an equation based on the variable given. The equation then needs to be differentiated with respect to time.